let's look at proposition number 33 of book 7 of Euclid's Elements. The proposition says, given as many numbers as we please, to find the least of those which have the same ratio with them. For example, A is 18, B is 27, and C is 36. So 18, 27, 36. So we have to find the least numbers which will form the same ratio. So in modern arithmetic, we know how to do that. Yes, just keep simplifying it to get how much. This is 18, so this will be 2. This is 27, so this will be 3. This is 36. This will be 4. So we'll end up with 2, 3, 4. These are the least numbers which will form the ratio as ABC. Right? But that was just an example. Now let's see how we can prove that these are the least numbers that can be formed given these three numbers ABC. Okay, let's begin. Given numbers ABC, either ABC are relatively prime or they are not. If they are relatively prime, they are the least numbers forming the ratio. You can't simplify them further. But if not, first thing we do is we find the GCM of ABC, that is D. Let there be as many units in numbers EFG as there are D's in ABC. So how many? So GCM will be some number of these three numbers. So how many of these is required to make up A? That multiple will be E. Similarly, how many D's are required to form B? That will be the number F. And how many D's are required to form C? That will be G. So we have EFG. So which means EFG measure the numbers ABC respectively according to the units in D. And we know EFG measures ABC the same number of times. That is D number. Okay. EFG are in the same ratio as ABC, which is what this means. Okay. So EFG are the least numbers forming the ratio. What we have to show, we have shown that EFG are the simpler forms of ABC in terms of ratios. What we have to show is that these are actually the least numbers possible. So let's see how we can prove that part, that these are actually the least number. Now, for this, what we do next is, if EFG are not the least numbers forming the ratio, then there must be lesser numbers HKL forming the ratio. So let me form those numbers HKL. H measures A. Since we are saying that these numbers form the same ratio, that means H measures A the same number of times that KL measures B and C. Let there be as many units in M as there are H's in A. So since we have looked at H's in A, that means KL measure BC based on the units in M. So which means, remember, H's measure A and KL measures BC. That means HKL measure ABC. And because these measure ABC and they are based on the units in M, we can say M measures ABC. Now, because we have said let there be as many units in M as there are H's in A, that means A is equal to H times M. And previously we have seen E measures A based on the units in D. So A is equal to E times D. So we have four numbers, which means we can form this ratio. E is to H as M is to D. Okay, so since we have this proportion, and here if E is greater than H forming a particular ratio, M will also be greater than D because the ratios are equal. So E is greater than H means M is greater than D. This is impossible since D is the GCM of ABC. GCM is supposed to be the greatest common factor. So M cannot be greater than D. So which means E, F, G are the least numbers forming the ratio. So that is proposition number 33 of book 7 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you feel somebody else can also benefit from it, please do share. That's it for now.